right, it's going to go on page 119 today. We are going to work through some proofs real quick, and then you're going to have some time to work. Number 1 is actually on page 118 in your ISN. I did it yesterday. It had thetas in it, not alphas, but I'm not going to work the exact same problem that we did yesterday. So, all right, so let's look at number 2. I have tangent of a over 2 equals cosecant a minus cotangent a. So which side would you rather work with? The left? The right? Work with the left? Okay. Matter of opinion, but okay, so that's fine. We can go with left because it really doesn't matter. We can do either way. So we're going to work with the left. This is our goal. Okay, so when you have tangent of the half angle, you have 3 options as to what to substitute in. I think we can all agree real quick on which one not to do. Would you agree with that? Okay. Then of the next 2 that you have to choose from, which one do you think would be easier to work with? The second one? Yeah, because it would be better to have the 2 terms in the numerator than the denominator most of the time. So we will do that one. So this is going to be 1 minus cosine A over sine A. And that equals cosecant A minus cotangent A. So then what should I do next? Split the fraction. So 1 over sine A minus cosine A over sine A equals cosecant A minus cotangent A. One other thing about the work that I've been seeing on this stuff, some of you are leaving off your variables. Like you just have cosine and sine and tangent. You have to have the A or the alpha or the theta. Like you have to have the whole thing every time, so don't get sloppy with that. All right, then what is 1 over sine A? Cosecant A. Minus cosine over sine is cotangent, and that's nice because that's what this side is, cosecant A minus cotangent A, and we are done. Okay. Everybody okay with all that? All right. So let's look at number 3. I think we could agree we want to work with the left-hand side. Yes, so this will be our goal. So we do have double angle identities, but these are squared. So I don't know that I want to necessarily go with the double angle there with the squared in it. But I do have power reducing identities. Look at those down there. That's not something that we've officially used until today. And you actually won't need to use it on your assignment, but we're going to use it on this problem just so that you've at least seen how it works and used it once. Okay. So a cosine squared will actually equal 1 plus cosine 2 theta over 2. Y'all see that on the power reducing? All right, the power reducing, so that cosine squared. So when I substitute it in for cosine squared, this is going to be 1 plus cosine. Now it's cosine of 2 times the angle, and the angle is 2u, so that becomes 4u over, oh, you forgot your, yeah. Oh, they're not? Okay. Because on this chart it says cosine of 2 theta, and theta is 2u. We're power reducing over 2, yeah, just like I said. Minus, and then the sine squared, so when I substitute in for sine squared, it's going to be 1 minus cosine of 2 theta, so that becomes 4u all over 2, and that equals cosine for u. For u, that's right. So then I know when I combine my 2 fractions on the left, my denominator is 2. What would the numerator be? No. Because I'm not multiplying. The ones would cancel out. So it kind of looks like a difference of squares, but we're not multiplying, so it's not. But if I do the 1 minus 1, they zero out, right? 2 cosine, good. So 2 cosine 4u. And that all equals, yeah, minus a negative. Then these 2's cancel out, so you get cosine for u equals cosine for u. Aren't you special? You all get cosines. Feel like Oprah. It's cosine for you and cosine for you. All right. You get a cosine. All right. So let's look at number 4. We're not going to use we won't use the power reducing here. Like I said, you won't even apply that on your assignment. I just wanted to at least use it once because we're not going to go over those. But I do have half angle formulas. Now, with my half angle formulas, they are, it's not sine squared, it's sine. But anytime you have sine squared, it's just sine times sine. So it's just sine of the half angle times sine of the half angle, which means you can just take whatever that rule is and square it. So when I look at my x over 2, and I find that on my half angle identities, I only have one choice, right? And so this is going to be plus or minus the square root of 1 minus cosine of x over 2. So that's sine of the half angle, but I need to square it, so it looks like this. Okay, because it was sine squared. Now, I don't have a cotangent of a half angle rule on here, but I do have 3 tangent rules. I can use those by just doing what? Flipping them, by using the reciprocal. So if I use the reciprocal of the tangent rules, of those 3, when I use the reciprocal, looking at those on here, not staring at me, looking at here, which one of those 3, first, second, or third, do you think could be most helpful? Okay, so on cotangent, I'm sorry, first, second, or third of the tangents is what I should have said, of the tangent of the half angles. The third one looks easier. Okay, but remember, we're going to use the reciprocal, and we want it to help us. I would go with the second one. So when I use the reciprocal, that gives me sine of x over 1 minus cosine x. And that equals 1/2 sine x. Now, I could have used the other ones. The square root one would have made it weird because I'm not squaring that one, so I don't know that I'd want to do that. But I still could have got there the other way. It would have just been more complicated. So when I square this first parentheses, that just gives me 1 minus cosine x over 2. Then I'm going to multiply that by sine x over 1 minus cosine x. That equals 1/2 sine x. Then what can I do? Cancel. I can cancel this with this. When I cancel those out, 1 is left up here. Not this 1, but, being multiplied by 1. So that means I get 1/2 sine x equals 1/2 sine x. And there you go. What questions do we have? Yeah, I think y'all just overthink things sometimes. And I will say this again, I'm sure I said this yesterday, but the majority of the problems that I have been seeing have absolutely nothing to do with trig and nothing to do with pre-cal. It's basic algebra stuff that y'all are just ignoring and making stuff up. And fraction rules. I mean, you don't know your fraction rules and how to handle fractions, and that's causing you to not be able to handle anything. And yeah, so I mean, at this point, I don't know. All right, so let's look at number 5. I think the right side looks more complicated. Would you agree? Okay, so let's make the left side our goal. So sine 2x minus tangent x. All right, so now look at the right-hand side and tell me what's going on in the numerator. What is this kind of situation called that you should be able to recognize? It is a difference of squares. Okay, because there's no cosine to the 4th anything on here, right? And so this is a difference of squares. So I'm going to factor into cosine squared x plus sine squared x times cosine squared x minus sine squared x, all over cotangent x. Hey, look at that. All right, so well, let's pause here for just a second, because another thing I think is causing some of you to run into roadblocks is you're trying to do way too much at one time. It is true that cotangent is cosine over sine, but I don't know that I want it to look like that at this point, so I'm not going to substitute that in. Like, I got a lot going on in the numerator I need to take care of. I'm going to let the denominator just hang out there for a minute, okay? So it's okay to do more than one thing at a time, and I even will on one of these two, but it's like, what are you doing? You don't want to jump in and just like do everything you can, because you might be, jumping over a step that would have actually been helpful. Okay, so let's talk about this other difference of squares, right? If I factor that, that'll give me cosine x minus sine x times cosine x plus sine x. When I just have cosine x and sine x and I'm adding them, does that really do anything for me? No. So even though it is a difference of squares and we should recognize it, I don't know that I want to do that here. Okay, so maybe, but let's just hang on before we get ahead of ourselves. Yes. So sine 2x minus tangent x equals, yes, so cosine squared plus sine squared is 1, and it's going to multiply by that, so I'm not even going to write that down. Besides factoring it, which I could, but I think we'd factor it and be like, I can't do anything with this, so I'm going to multiply back together. What else could I substitute for that second one? Yes. Look at your chart. Don't stare up here, because staring up here, unless you have it memorized, I don't know how that's helping you. Not -1, no. It's the double angle. If cosine squared minus sine squared is cosine of 2 theta. So I can do cosine of 2x up here over cotangent x. The double angles. So even though you don't have to have these memorized, if you're actually using this and actually doing all of your work, some of them will start to look familiar. You'll at least say, hey, I think that's on the chart. I can go look for it. You know what I mean? Like they start to, maybe you can't rattle them off, which is fine. You don't need to. But some of them should start looking familiar and you know what to look for. It just doesn't look like I have a minus sign here. Okay. Double angle, cosine squared minus sine squared. Yes. It is not -1, no. Because if I have cosine squared, so we know that cosine squared x plus sine squared x equals 1, right? If I multiply through by a -1, that gives me negative cosine squared x minus sine squared x equals -1. And that's not what I have there. Does that make sense? And then if I try and force it by factoring out a -1, I'm just right back here. So there's like no way to make that into this. Does that make sense? Okay. All right. So now let's think about what our goal is. So proofs are better than just simplifying because I at least know what my goal is. And my goal has a tangent in the numerator. So yes, cotangent is cosine over sine, but it's also 1 over tangent, right? So in the denominator, if I just change this without rewriting everything and put 1 over tangent x, like that's the same thing, right? I'm going to rewrite the left-hand side, sine 2x, not equals, dang it, sorry, minus tangent x equals, so when I multiply by the reciprocal, this will give me cosine 2x times tangent x. So I have a tangent in the numerator now. I still don't have 2 terms, but I can get there. Now, I realize that we just put cosine 2x in there. But in the end, I don't actually want it in there. So is there something else that I could, since I have choices for cosine 2x, is there something else that could help me by substituting back in for that one? Yeah. 1 minus 2 sine squared? Okay, well, let's think about it this way. Don't think in terms of sine and cosine. Think in terms of whatever I substitute in for this, it has 2 terms in it, right? And this tangent will have to be distributed. In the end, I want minus tangent x. So which one of those would help me get my minus tangent x? 2 cosine squared minus 1. Does that make sense? That's why I would choose that one. Again, if you chose a different one, you could still get there. It would just take you more steps. So sine 2x minus tangent x equals, so this is going to become parentheses 2 cosine squared x minus 1 times tangent of x. Some of y'all are just not putting in parentheses on this stuff either, and then that's why you can't get the right answers. And that, again, is an algebra thing. And trying to skip too many steps. I know it's a lot of writing, but I'm telling you, you're gonna confuse yourself when you're skipping stuff. So now I'm going to distribute. I'm going to rewrite the left side. Sine 2x minus tangent x equals. Now I'm going to distribute that tangent. So this is 2 cosine squared x tangent x minus tangent x. So we're getting closer, right? I think I need that cosine and I need that tangent into its reciprocal that's multiplied right here. So sine 2x minus tangent x equals 2 cosine squared times sine x over cosine x minus tangent x. So now I can cancel this with one of these. And this leaves me with 2 cosine x sine x, which is the same as 2 sine x cosine x. And what is that? Sine 2x. So sine 2x minus tangent x equals sine 2x minus tangent x. This 2 sine x cosine x, if you look on your double angles, it is sine 2x. The double angles. See how that works? We good? Yes? Okay. All right, let's look at number 6. So I think on number 6, we definitely want to work with the left-hand side, yes? Okay, so in the numerator, I've got sine squared. We know how to handle sine squared just fine. And sine y. But that sine 3y, there's no triple angle, right? Last time we had a triple angle, what did we do so we could do something with it? We split it up. All right, so I'm just going to rewrite the numerator. So 4 minus 4 sine squared y over, now I'm going to make this sine of 2y plus y plus sine y. And that equals cosecant y. All right, so now, in the denominator, I have, this is like sine of a plus b. So find your sum and difference in that sine of a plus b. So I'm going to rewrite the numerator, 4 minus 4 sine squared y. So in the denominator, this becomes sine 2y times cosine y plus cosine 2y times sine y, and then I still have that plus sine y over there. Okay. Now, I'm pretty confident that I want to get rid of the sine 2y and the cosine 2y, but I'm going to do them one at a time because, again, sometimes when you do too much at once, you eliminate an option that you had, and then you just get stuck in a rut there. So we'll rewrite the numerator. 4 minus 4 sine squared y. So sine 2y is 2 sine y cosine y, but since I already have a cosine y there, this becomes cosine squared y. Then I'm just going to rewrite the rest. Plus cosine 2y sine y plus sine y equals cosecant y. Because sine 2y is 2 sine times cosine, and I'm multiplying by another cosine. Because cosine of 2y is 2 sine times cosine. So, cosine. Yeah, there you go. Yes. All right, now look at the denominator. How many terms are in the denominator? 3. So look at each of those 3 terms. Do they have anything in common? Sine y. So can I factor, because I can't combine anything else right now. Can I factor out a GCF? Can I also factor one out of the numerator? So I might as well just go ahead and do them both at the same time. So in the numerator, I get 4 times 1 minus sine squared. Sine squared y, thank you. Over, then I'm going to factor out a sine y. That leaves me with, bless you, 2 cosine squared y plus cosine 2y plus 1 equals cosecant y. And there are parentheses there. Y'all see those parentheses? You have to have them. Okay? All right. So, the denominator, I need to get rid of that cosine of 2y, right? And then I know in the end I want cosecant y, which means I don't want anything. Like sine y down here looks pretty promising. But then up here, this kind of looks like it could be an issue. So since I know I don't want two terms for sure, can I substitute something for this? Cosine squared. So I'm going to go ahead and try and do, because the numerator and denominator don't really affect each other at this time, so I'm going to go ahead and make that into cosine squared. So 4 cosine squared y over, then I still have this sine y out here, times 2 cosine squared y, and then that cosine 2y. That one's tricky because I got 3 options. So I want to think about what might make the most sense. Like, do I actually want to introduce a sine squared into this thing right now? I really don't. So I think I'd like to use the one that doesn't have sine squared in it at all, which is going to be plus 2 cosine squared y minus 1, and then I still have this plus 1 that was there. And that's equal to cosecant y. So numerator, I still have 4 cosine squared y over this sine y. So in those parentheses, 2 cosine squared plus 2 cosine squared is what? 4 cosine squared y. Then minus 1 plus 1 zeroes out, so that's it, and that's cosecant y. Now, I have no addition anywhere. This is all multiplication, so I can cancel the 4's out. I can cancel the cosine squareds out, and I end up getting 1 over sine y equals cosecant y, which means cosecant y equals cosecant y. And there you go. Okay. What questions do you have? Okay, I will say again, practice, practice, practice. Like, you have to practice. You have to try and struggle through it. You have to be okay with making mistakes and going back and figuring out where they are and starting over, because what you did is just making it insane. Okay? Because that's part of the struggle. We good? All right. And I want to say again, the power reducing we did on the notes, you don't have to do that on the assignment. But on the assignment, there is one that you have to factor with the sum or difference of cubes. So you got to know how to do that. So I'm just telling you right now, don't be making stuff up.